The next thing I'd like to discuss that is part of the collections framework is going to be queues and the queue interface. So a quick overview of this section. I'm going to give a quick introduction for a queue, and then I'm going to give you a real-time example of a queue. Then we'll look at the hierarchy of the queue interface. We'll talk about features of the queue interface. We'll talk about how we can create a queue in Java, and then we'll do methods of queue interface and queue examples. Okay, so a quick introduction. A queue in Java is a collection of elements that implements the first in, first out order. So in simple words, a queue represents the arrangement of elements in the first in, first out fashion. And that means an element that is stored as a first element into the queue will be removed first from the queue. That is, the first element is removed first and the last element is removed last. So the Java collection framework added queue in Java 5, and it is present in java.util.queue. So a real-time example of a queue, you can think probably the most common example that you encounter almost on a daily basis would be a waiting line at, say, for instance, a supermarket. The cashier services the person that is at the beginning of the line first, and other customers enter the line only at the other end, at the tail, and wait for service. And as the first person is served by the cashier, the next person moves to the front. And that happens all the way until you cycle through the line of people. So the last person is the last to get service. So similarly, a queue in Java is a common data structure in which there are two ends, a front, which we'll call the head, and the back, which we'll call the tail of the queue. Elements are always inserted into the end or the tail of the queue, and they're accessed and deleted from the beginning or the head of the queue, as shown in this figure here. So we could think of adding the data 1, then adding data 2, adding data 3, and this is our collection of data. And then when it's time to go ahead and take data out, we take data 1 out first, then data 2, and then finally data 3. First in, first out ordering. So for this reason, a queue is a first in, first out data structure. The operations of inserting and removing elements are called in queue and dequeue. An element that is added to the end of a queue will remain on the queue until all the elements in front of it have been removed. And the process is similar to the concept here in America, we call them lines, but in the UK, across the pond, they call it queues. And it's analogous to that, like customer waiting and service. It's exactly that type of data structure or behavior of a linear data structure. So let's talk about the hierarchy of a queue interface. So in the Java collections framework, a queue is represented by java.util.queue interface. It is right here. And so that interface extends collection. And so it is a super interface of the blocking deck. So here we have the deck interface, which itself extends the queue interface. So the queue interface is implemented by several concrete classes, such as linked list or array deck, which we'll both look at. We'll look at both of those. Other ones that we won't look at would be array blocking queue, the abstract queue, which is an abstract class, and the priority queue. We will look at priority queue as well. So we'll look at priority queue, we'll look at array deck, and we've already looked at linked list. But we'll use linked list in some of our examples. Out of these, the array deck class is the best choice for simple FIFO. So first in, first out is also referred to as FIFO queues. It provides all the normal functions of a queue. So let's look at our interface declaration for the queue. So the queue is a generic interface that's declared in a general form as follows. It's public interface. It uses generic typing. So queue, where the data type would be replaced with this generic E, and then it extends the collection interface, which also supports generic typing. The features of the queue interface, there are several interesting features of the queue in Java that is follows. One, queue interface orders elements in a first in, first out policy. Two, elements can be accessed and removed only from the front of the queue, the head of the queue. Three, elements can be added only from the back of the queue. And four, queue does not allow to add the null object. So how do we create a queue in Java? Well, queue interface can be implemented in Java by using any of the four concrete classes that implement it. So that's linked list. We can't do abstract queue because that's an abstract class, but you can extend the abstract queue and make your own if you wanted to. The priority queue, which is a concrete class, or the array deck, which is a concrete class. So for simple 5-vote queues, linked list and array deck classes are the best choices to create a queue. And so when you need to create a queue, simply initialize a queue variable, because that is a valid interface, so it's a data type, and then you can instantiate either a linked list object or a array deck object as such. So here we would do our data type queue, and then that gives us access to all the queue methods, all the methods defined in the queue interface, and then we would use whatever our generic typing is, and then we can actually implement it. We can actually instantiate it using the linked list constructor or using an array deck constructor. So some methods of the queue interface that are worth mentioning. There's the add method where we can pass in an element, and the element will be whatever the data type that we've used generic typing on. So you would replace the E with whatever the specific data type is, and it's going to return back a Boolean value, true or false, on whether it was successfully added into the queue or not. And again, it can throw all sorts of exceptions if for any reason it could not add that element. They have the element method, which returns back an element. So it is used to retrieve the element that's at the head of your queue, but the element is not removed from the head of the queue. So this just lets you essentially look at what the head is, but it will maintain the ordering of the queue. It will maintain the state of the queue, won't change it. Then we have the offer method where we can pass in an element. And again, we're using generic typing here, but the specific typing would be whatever you specified it as. This is going to return back a Boolean value. This is used to insert the specified element to the queue. And so this method returns true if it's successfully added, false otherwise. We have a peek method that returns back an element. So this is used to retrieve the element at the head of the queue, and the element is not removed. It returns null if the queue is empty. So this lets you peek at the element. You also have poll, which returns back an element. This is a method that allows you to retrieve the element that's at the head of the queue, and it removes the element in the process. So this method returns null if the queue is empty. So this returns back and mutates the state of your queue, where this returns back but maintains the state of your queue. That's the difference between peek and poll. And then we have a remove, where that removes an element. This is used to retrieve and remove the element at the head of the queue. So again, and this throws an exception, no such element if the queue is empty. So here, remove and poll are pretty similar, except one throws an exception, the other will return a null value. Okay, so the methods that are inherited from the collection interface, because remember, the queue interface itself extends the collection interface, would be add all, remove all is empty, clear, contains all, equals, hashcode, iterator, retain all, size, and to array. I'm not going to go through all those because we've done that many times. Just know that any queue interface, clearly like a linked list or a array deck, would have those as well. So some quick notes: the poll and remove methods are similar, except that poll returns null, and if the a null object if the queue is empty, whereas the remove throws an exception with no such element exception. The peek and element methods are similar, except the peek returns a null object if the queue is empty, and the element throws an exception, no such element exception. And the offer method is used to insert an element to the queue. The method is similar to the add method inherited from the collection interface, but the offer method is more preferred because these are typically the labels we use as actions one can do on a queue: poll, peek, and offer. So let's take a look at some example programs to perform various operations based on the above methods defined in our queue interface. Okay, so let's go over here and actually, so let me close this and let's go to our queues and stacks. So here I want to close all this pre-existing files. Let's go to our queue tester. And I'm going to run it so that we can look at the code while I talk about it. Okay, so the first thing I'm going to do here is I'm going to go ahead and I'm going to import the queue interface from java.util, and then I'm going to import the concrete class linked list so I can instantiate an instance of a queue. Then I'm going to create a class queue tester so we can have a main method so we can actually create some code and execute it. Then I'm going to create a queue, a variable of data type queue, and for generic typing, I want to specify a string, so a queue of string elements, and I'm going to use a linked list to instantiate and save my queue variable. And now I'm going to illustrate that I can use the add method, right? Now, it's preferable that I would use the offer method, but I can use add. So here we'll add elements. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. And then I'm going to print out the initial state of my queue. So that's going to be here, elements in queue. You see it's in the order that I added them in. Then I'm going to do queue.element to get the head element of my queue, and that's going to be ABC here. Then I'm going to remove the head and get that value back. So here you can see the removed element is ABC, and the new state, if I print that out, is now going to be DEF, GHI, JKL, MNO. Now I'm going to offer up an element into my queue, that's PQR, and I'm going to print, and I'm going to go ahead and print out the return value of this. So that's going to return a Boolean value, whether we're successful or not. We successfully added that to the tail of our queue. So now if we inspect our queue, we can see that PQR is now at the end of it. It's the tail of our queue. Excellent. Let's look at another example where we use peek, pull, and remove methods, and using an underlining linked list as our implementation, just like this last time. So here, let's go ahead and import our queue interface. Let's go ahead and import a concrete class of linked list so we can actually instantiate an instance of queue. Let's go ahead and create a class that has a main method so we can create code that executes. I'm going to create another queue variable with the generic typing of data type integer. And I'm going to create a new linked list to serve as my queue. Here, because of my collections interface, I can query, is my queue empty? Is empty, and I'm going to print out the empty state. In fact, let me run this right now. And I can see, yes, it's true. My queue is empty initially. And then what I'll do is I will try to peek and pull an empty queue. So here, if I peek, I get back that null reference. If I pull, I get back that null reference. So this is the one that doesn't throw exceptions. It throws the null reference to let us know that there's nothing remaining in our queue. Then what we're going to do is we're going to use the collections add method to add our elements. We could also use the offer method, which would be the preferable means. And here we'll add in 10, 20, 30, 25, and 50. Then we'll check the size, which again is a method we get from the collections interface. So here we see that our size is now 5 after adding 5 elements. We are going to print out the state of our queue. Here's the state of our queue here. So 10, 20, 30, 25, 50. Then we will remove an element from our queue and save that here into this variable that we'll call head. We'll print out the head, and then we're going to print out the state of our queue after the remove method. So here, the removed element was 10. And now the new state of our queue is 20, 30, 25, and 50. And here we're going to go ahead and peek and examine. We'll print out the state of P that returns that head element, but then we're going to look at the state of our Q, and we could see that that doesn't mutate the state, doesn't remove that element from our Q. So here we get back the head, and if we look at our Q, it's still 20, 30, 25, and 50. Excellent. And so there's one other example that I want to show. So far, all of the examples that we've seen up to this point have used linked lists, but I'd also like to go ahead and take a look at array deck as a means for implementing just the interface of just for holding a Q variable data type. So let's jump back on over here, and we will open this up. And so for here, I will go ahead and I will import my array deck, which is my concrete class. So I can instantiate a instance of Q, and I'm going to import my Q interface. I'm going to create a class here, QTester3. I'm going to create a main method that allows us to go ahead and produce code that will execute. Here, I'm going to create a Q variable, and we're going to use the generic typing of integer, so it holds integers, and I'm going to instantiate array deck. Now I'm going to use the offer method to go ahead and insert some integers into my queue, so 50, 50, 60, 20, and 10. Let me run this so we can look at the output. Okay, so here I will go ahead and print out the initial state of my queue. So that's going to be 50, 50, 60, 20, 10. Then I'm going to call the element method, which is going to give me back the head of the queue. Then I'm going to, but it's not going to mutate it. Then I'm going to call the remove method, which is going to remove the head of the element. And we'll print out that, and then we'll look at the state of the queue to see how it changed. So here, from remove, we get back the 50, the head element. And here we see that we've now decreased in size. So now instead of 50, 50, 60, 20, 10, we're at 50, 60, 20, 10. Here we'll call the remove method again and print out the state of our queue. So again, we remove the next 50, and now the new state is 60, 20, 10. Here we're going to offer up a new value into the queue, 100, and print out the new state of our queue. So here, after doing that offer, we can see that the state is mutated. We've added something to the tail. So it's 60, 20, 10, 100. And here we're going to remove another element and print out the state. So here we remove the 60, and our new state is 20, 10, 100. And so that is a quick, just a quick explanation for what the Q interface is and how it adheres to what's called a FIFO policy, or FIFO policy, first in, first out.